चलो
गुड मॉर्निंग मैडम.
हॅलो.
गुड मॉर्निंग मॅडम. माझा आवाज येतोय?
हो, मला येतोय आवाज.
ओके.
स्टार्ट करू का?
येस मॅम.
Good morning, everybody.
गुड मॉर्निंग मॅम.
Welcome to day 2 of online workshop on Android-based automation. This workshop is sponsored by Dr. Babasaheb Ambedkar University, Loneri, and this workshop is conducted by Electronics and Telecommunication Department of Sri Siddheshwar Women's College of Engineering, Solapur. Today's first session is conducted by Mrs. Manasi Vaidya. She is an embedded software developer with 3.2 years of experience. She has managed all aspects of development from designing hardware, software to actual product dispatch. She has led the embedded team of 8 people for 1 year and had the opportunity to dispatch 40 modules for government project during that time. She has led the team of 4 people to guide more than 100 projects for final year engineering students. She is an engineering postgraduate with specialization in VLSI and embedded system design. She scored overall CGPA of 8.8 and bagged second rank in college. Along with her degree, she completed C, C++, and Java courses and learned various technologies which has helped her to complete a final dissertation work. She has published a research paper, Design of 2-bit magnitude comparator, in Journal of Emerging Technologies and Innovative Journal. We are glad that ma'am could join us and share her knowledge with us. Ma'am, you can start your session now.
Yes, thank you, ma'am, for introducing me. Hello, everyone. Ma'am has introduced myself in well manner, so I will not waste my time introducing myself again. But one thing I can assure you, I have completed more than 100 projects on a BE level project also. That is the added thing upon it. And I have assisted many electronic students, computer students in that. Now I will start sharing my presentation screen to start our session. Is easiest way to okay. Share a screen. Entire screen. Okay, share.
I'm sorry for interrupt.
Yes, ma'am. Yes, sir.
I will share you the YouTube link on your mobile that you can see the comment of the students. Simultaneously, you can present your screen.
Okay, sir. Okay. So I am able to see the messages. Hello. check my WhatsApp link. Uh, okay. So now I'm able to see my all the comments. So today's lecture is Arduino and its application. So basically, ma'am said we have a session for the application of the any controller with the web development. So basically, we will start with a simple controller because we don't have only electronic student, we have other students as well. So I will take a simple controller. Basically, I worked on three controllers: ARM controller, Peak controller, and Atmega and Arduino. Arduino is a very simple controller and we can use it for the prototyping. So we will take the simplest controller for now because our focus is for the web application developments. So I will start with introduction to Arduino and what exactly is the Arduino. So wait a moment. I just need to check what exactly is happening with my screen. Um, okay. So I will. So basically, student, I will stop my camera right now because we will focus on only presentation. So I will speak, and if any doubt is there, you can text me through the chat box. Am I audible? Could you please reply on chat box? Hello. Am I audible to you? I think yes, I'm audible.
Yes, ma'am, you're audible.
Yeah. Okay. So quickly we will go through the contents. Introduction to the Arduino. We will start with the introduction. How we are getting started with the Arduino board. Then what exactly a software we require to program a Arduino board, which is Arduino IDE. Then we will focus on two controllers, which is Arduino Uno and Node MCU. I guess all of you know about Node MCU. It is nothing but the Arduino controller embedded with a ESP8266 Wi-Fi module on it. So basically, we don't need to interface any Wi-Fi communication to the Arduino. So we use Node MCU in industry also. Then we will go through the basic GPIOs UART, which is serial communication. Then what is ADC, PWM. Again, we will start how to add library in the Arduino IDE because in the Chrome or in Google's age, we always get ready-made codes, but we need how to execute that code. We have code in front of us and we cannot download it to the controller, so that will be our problem. So I will explain that also. Then again, we will go through the Bluetooth module, which is um also what we can say, it is very important as per the web application, because if all of you know about the Alexa thing, when we buy a Alexa, we need to set a user ID and password. And how it is getting set? It is getting set through the Bluetooth. So Bluetooth is also an important thing for a web application. Then we will go to the actual web application. We have two projects. ESP8266 Wi-Fi module interfacing with Arduino, or we will use the Node MCU, and one home automation application. I know it sounds very typical, but home automation is really very difficult in real-time basis. It is not a prototyping. It is actually real-time execution of the home automation. So we will go through that also. Now we will start with the introduction to Arduino session. So basically we will start with what exactly is the Arduino. So Arduino platform is a open source hardware and software that is easy to use and is used widely for the hobby projects and prototyping. So you are engineering students right now. I know you are not pass out students. So you can start prototyping your ideas through the Arduino because it doesn't need any kind of PCB design, or we will reduce any hardware designs using any other controller like Peak, ARM, or any other thing. So we will get a ready mode board like Arduino. So in market we have four types of boards like Arduino, Raspberry Pi is also there. Then we have also development modules like STM32, which is based on ARM. But we will start with Arduino. So what exactly is open source? So could anyone can write what exactly is the open source for me on the chat box? Does open source means only free software or anything else uh, is there? Open source Windows. No, what I am asking, what exactly is the open source software? Yeah, Bhavana is writing it's free of cost. And what we know about open source? We can use it without paying any amount. Yeah, that's the same thing. Publicly available. Yeah, correct. Okay. I will go with the Sanjana's point. Publicly available. What exactly is publicly available means? So it means that all the information regarding the hardware and software that Arduino provides, it's freely available. So any open source software means how it is developed, how it is working, how we can use it. That information will be there in free of cost. It is not only that we can use it freely and we don't have to pay anything. It is that we have all the information regarding the software. So I will take the example of MATLAB. Is MATLAB freely available or not? So I will again ask the question: is MATLAB software is free or not? Shruti Saket is saying yes. Is MATLAB free? No, its cracked version is free. Cracked version of MATLAB is free. But if we want to buy MATLAB or access every feature of MATLAB, we need to pay. Trial version is free. Yes, correct. Shrutika is saying trial version is free. So it is actually MATLAB is very heavy software to communicate with, but it is widely used for image processing. So it is useful software. We have to buy that instead of buying a cracked version. Okay, I will add one more point on the open source. They provide the design for their hardware and software. Anyone can use these designs to manufacture the hardware and can distribute the software. So I will go to the basic point that is anyone want to start or develop his or her own product, because in electronics and as per the software development we can develop our softwares or our hardwares sitting at home, so we can start our product launch, right? So that's why these boards are very useful, because firstly they are easily available, actually they are ready made, and we can build a actual application within 2 to 3 days. Someone Ram is saying, what is extension of Arduino? Okay, publicly accessible, anyone can see and modify. Yeah, extension of Arduino is Node MCU, Arduino Mega, all those things. Okay, so we will try to keep our question and answer session at the end of the presentation, I guess. Why we are using Arduino? So that will be my third point. Arduino provides many types of boards which are useful for various applications. So, do you? I think I will stop talking about electronics. We need to talk about software development also. So we will go forward it. Arduino also provides its own IDE, which is free of cost. Many libraries are provided with the software, and large number of libraries are developed by people from around the world are available for free. So this allows the user to use certain interfaces or modules. Then Arduino board, we have various features in Arduino board, Arduino IDE. Okay. We have many Arduino boards, like I said, Uno, Leonardo, Nano, and Arduino Lilypad, Mega, Pro, Zero. Um, Many of them are available. Now, Arduino IDE. Again, Arduino IDE is free of cost. Um, Now we will directly go to how getting started with Arduino boards. So I know this is a very basic diagram. We have a laptop with us and we can connect it through a serial port and C type connector, or we have a charger type 5 volt adapter to connect or to power on the Arduino board. In order to write a codes for various applications and to program the Arduino boards, we require the Arduino IDE. The Arduino IDE is available. Wait a minute. I will show you the what exactly is the Arduino IDE screen. Yeah, basically this is the Arduino IDE. Okay, 98 people has joined. Hmm. Now, in order to use the Arduino boards with the Arduino IDE, we need to connect the board to the laptop, as I shown in the figure. I shown this on the figure that we have to connect the board. So when we connect it through the USB, we don't need to give the external power supply to it. So it is very handy. Connect the board, download the code, and start observing your application. Okay, so basically um, this is the Arduino IDE. Everyone is able to see, right? Mm, okay. Uh, I will try to connect my board also. Just a moment. So are you able to see the various boards available for the Arduino based? We have a Arduino Uno, we have Nano, Mega, Leonardo, then Micro, then again we have the what I said to you is Node MCU. Yeah. So we have many boards. Which one we buy? We select it from the tools, then select the board, and for now I have selected the Arduino Uno board. Yeah. So I have selected the Arduino Uno board for this. Clear screen please. Mm. Do we have setting on the portal that share a screen? StreamYard, cam, settings, camera, integrated webcam I have. Green screen. Mm. Increase the size. Um, so, is anyone know how to install the device driver for the new mouse? If we connect a new mouse through the USB, do we need to install the device driver for it? Yeah, I have increased the size of the screen. Is it visible now? No. Why it is not visible? Yeah, it's visible from the current screen. Okay, just focus what I'm saying. So if we have to connect a new mouse to our laptop, do we need to install a device driver or not? No, drivers will be installed automatically. If not, then we have to scan for the hardware changes. So Raj is saying that we have to scan. So if we connect the Arduino board externally, we need to install the device driver for it. So how to do it? Installing a device driver. Same screen which occurs when any USB hardware when we connect. Then we scan for the ports, then we get the unknown device if device driver is not selected. So basically we need to install a device driver for the Arduino board. So these are the steps to update the device driver. Update, we will right click on it and then we will click on update driver software. Then we will click on browse my computer for driver software. Then we select a driver which we have already downloaded from the Arduino IDE website. Then we will click on install button. Yes, then we will get, we have the Arduino Uno board which is connected to the COM9. So Arduino Uno is connected to the COM9. Why it is so important? Because we have a Arduino IDE with it. Then if we want to download a code, then we will need to select the board information and on which COM port it is connected. So port is COM4 because I have already installed the device drivers for it. So my Arduino Uno is getting detected. Okay, so while we are doing the same thing, I will connect. Okay, I will show you afterwards these things. COM4 is connected and we are going to select it. I will show you that practically. Device manager. Then click on device manager. Scanning ports. Scan hardware changes. I hope all of you are able to see what exactly I am doing on my computer screen. So what exactly I am doing? Scanning port. Scan the plugins. So in that we have ports option. Are you able to see it? It's a ports option, and on that ports option we click on COM4. We can see that we have a COM4. What is connected to COM4? It is Arduino Uno. So these are the basic settings to continue with the boards. I guess you can do it on your laptop simultaneously. What I am doing. If you want, otherwise you can call me or message me accordingly. So basically what I shown you on practical basis, that we have selected a port. Here it is COM9, but on my laptop it is connected to COM3. Then this is a Arduino Uno board. Then we will start coding. So for electronics engineer, this is the shortcut, and they should not use this, but computer engineers can use it because then they don't need to waste time on the coding embedded things. So we will go to File, Examples, Basics, and Blink. What is Blink? It is a LED blinking code. Then we will select a board. Every time when we start coding, we will check whether the board is correct or not, whether it is connected to any serial port or not. So this is a repetitive step, but we have to confirm it again and again. Then we have these buttons on the Arduino IDE, that 1 2 3 4 5 6 7. Okay, 7 buttons are there. So I will show it on the real Arduino ID where they are situated. Mm, using Arduino ID. Okay. So this is to use to verify the code if our code is correct or not. So I will give the demo of it saying I will delete this semicolon and start verifying it. So here I can see compiling sketch. So every code which is written on Arduino is known as a sketch. Okay, so they have told me what exactly is the error. It is expected colon or colon before void. So I have to place a colon. After that, what I will do, I will verify it again. So it is getting verified. Up to that, I will explain you other buttons. This is used to create a new sketch. This is used to open an existing sketch or built-in example. This is used to save. This is used to upload the code to Arduino ID. So after compiling, I got that done compiling, which is the code is correct. Now I will upload the code to the board. So for some time, I will show you the board. This is the Arduino board. My screen is visible, I guess. Can I make it full screen? Anyways, you can see it, right? This is the Arduino Uno board. And this one is a Node MCU board. So I have many things with me, like breadboard, connecting wires, resistors, etc. One should have that at your home as a developer. We will come back to compiling. Yes, what I get is done uploading. So now the code is uploaded on my Arduino Uno. So am I writing it on a serial monitor? No, I'm not writing it on serial monitor. File, examples, basics. After that, what we can do, read analog voltage. We can take that example also. So in this example, what is written? Void setup is setting up your parameters over here. Serial begin is nothing but start your serial communication with a baud rate of 9600. After that, we have a void loop content, which is a while in terms of Arduino ID. How we use a while, which is never ending loop. According to it, we have a void loop in Arduino IDE. After that, we can sense a sensor value through the analog grid. So I will come towards that. I'm just explaining the structure of the code so that I can show you what exactly is getting. So again, I can upload this code directly to the Arduino because all the codes written on the examples files, examples, and all the codes which are available here are verified, and they are we can use them directly without thinking. So sometimes Arduino reduces our thinking process, but when we need to check the sensors or we need to develop application within 2 days, we use the Arduino boards. Okay, so this is a serial monitor. We can see a serial monitor. Why I'm not getting the values over here? Because the baud rate is not set. Baud rate is 115200, but in the code I have written 9600. So I will write a 9600 so that I can get the value. I hope everyone is able to see the readings. 1.16. Hello? I'm not getting any replies at the chat box. Okay. Yeah, someone wrote. Yes, yes, ma'am. So you are able to see the values on serial monitor. So these are the basic settings of the Arduino. Each one of you should do easily. After that, we will move towards the next step. That what exactly is the board? Oh, we'll start it from the that side. Exactly is the board. Okay, from comments. Okay, this is our Arduino Uno R3 board. Is it visible? I guess yes. I will not ask this question again and again. I think the software is working well. So these are the analog pins. Is my cursor is there? These are the analog pins. This image is not clear, but I will tell you what exactly it is. These are six analog pins: A0, A1, A2, A3, A4, A5. Then we have 0 to 13 means 14 digital pins, or some pins are PWM pins, and all those things I will explain. So 0 to 13 are the digital pins. We have SCL and SDA with uh, which is the I2C connection. After that, we have the serial communication pins 0 to 1. Here, TXD and RXD is also written. So we don't need to design a circuit, or we don't need to design a PCB. Then we don't need to go to the foundry and get the PCB, then place the components and then start working. We will start working directly with this board because everything is there on the Arduino board. After that, the basic concept, because we are moving towards the sensing parts, so we need to go through this concept. So when uh, we are connecting a switch to our Arduino board, the connection is like this. We have a switch over there, then we will connect one another pin to the input pin of the Arduino, and we will connect the other end of the switch to ground. So this condition is known as a high impedance state. And the pull-up resistor is, this is the switchboard. Then we will connect it to the input with a pull-up resistor, which is connected to 5 volt. So just remember this. Now we will go to the basic uh, code of LED blinking, which is the traditional code. Um, yes, correct. So control the LED via switch. So are you able to, I guess all of you are able to see the picture. Mm. So the LED is connected to the 13th number. This is anode and this is cathode of the LED. We have connected a 220 ohm resistor. Why we have connected this resistor? Because when we turn this pin as a high or a low, if it is low, then it will connect directly to the ground. But when 13th pin will connect to 5 volt, then we cannot directly give 5 volt to the LED. So we need some resistance. That's why we have used the 220 ohm resistor. After that, I have connected one switch, and now it is grounded. So we will start coding about it. We will connect a push button to pin number 2. Then we will declare LED at pin number 13. Then on the void setup, what we will do, pin mode push button. We will declare push button and input pull up. It is like a input pull up. What I have explained. This is the pull up because we have connected one resistor over it. So this is the pull up thing. Then we will start reading, but for now I will not go into the coding part of this particular diagram. So we will get the serial monitor. After that we will set the baud rate. Baud rate is set as 9600. And we will start getting values as I shown you. Okay, so how many of you know about ADC? I'm not getting the response. So basically, as I told you, we have 6 ADC channels. This one is a pot resistor. Okay, Pragati is there, I guess. Only Pragati is listening. Okay, so this is a pot resistor. We are giving reference voltage to pot resistor as a 5 volt. Then we are giving the analog input to the A0 pin, and we will connect a ground to the ground port of the uh, what is this, Arduino Uno. Then we will start writing digital output value for the ADC pins. So what are the functions for the Arduino ADC? I will go through the read analog. So analog read is the main function to write analog read A0 is reading a analog value at A0 port, and analog read A1. So if I am connecting analog sensor to the A0, A1, A2 pins, then we will change it accordingly. We will change it to A1, A2, A3, wherever we are setting our analog sensor. So why I am focusing on the analog sensor is if we want to develop a device for, let's see, what is the current scenario. Yeah, so we need to get the body temperature of the people. So what exactly happens there is, we will get the analog value, we will get the temperature in the analog format through the to any controller. So that's why ADC is required. ADC is used to convert the analog value to the digital value. So that's why I'm focusing on ADC. So what will happen? The actual analog value, which is in the form of the sine wave, is converted to the digital value, and we will process it according to our controller. Okay, reading the analog voltage and converting into the actual value. So where application of the ADC is interfacing a joystick to a controller, interfacing a accelerometer to the controller, or interfacing the temperature sensor, which can monitor the room temperature to the controller. So that will help us to read the actual values. So to develop a web application, we exactly need the analog values over that. Now we will move towards the, okay, so PWM, another difficult concept, I guess, for everyone. So what exactly PWM does? Is pulse width modulation. So when we think about pulses, we always think that pulse is like 50% on, 50% off. This is our understanding about pulse. But what we can do, we can change the on period and the off period of the pulses. We will change the on time and the off time of the pulse. So, what exactly is the duty cycle of the pulse width modulation? I'm not able to. Where is a live chat room? Duty cycle is the on period of the pulse. So here the duty cycle is 50, because out of 100% only 50% is on. So duty cycle is 50%. Here out of all the 100% pulse, 10% time the pulse is high, that is pulse is on. That's why the duty cycle is 10%. Here the duty cycle is 30%. Here the duty cycle is 70%. So what exactly it does? It turns on the device for 10%. It supplies the power to the device for only 10% according to our need, and that is required to uh, uh, it is required for the AC on off period. Because if we want to develop AC controlling, then we cannot directly turn off the AC. We need to control the temperature through the web page. So that's why we cannot directly turn off the AC. We need to slow down it, partially off it, and partially turn it on, or we can change the temperature using these pulses. That's why pulse width modulation concept is very important. After that, as I said, we need to check out the HC05 Bluetooth module, because for interfacing the devices like Alexa, we can also develop our own Alexa. And to configure the Alexa to the home Wi-Fi network, we need to communicate to that device through a Bluetooth. So what we generally do, we turn on our Bluetooth, we connect our mobile's Bluetooth to the Alexa, then we get the all the setting parameters, then we check the username, then we change the username. We can change the username, then we can set the Wi-Fi. For me, it's Mansi Vaidya, and my Wi-Fi's password. So that's why Bluetooth module and Bluetooth interfacing is also required. Now, how we can interface the Bluetooth to Arduino? So this is the block diagram. Here we need some resistors 1K and 2K. Then we are connecting it to the HC05 Bluetooth module. Then red line is the supply, and black line is the ground. So if you want to execute this Bluetooth interfacing, you can contact me through mail, so that I can give the code or block diagrams or any kind of material through the mail to you, so that you can read and do it on your own. And these things are available at the cost of 350, and this Bluetooth module is also of rupees 100 or anything. So within 500 you can design your own application at home. So this is the Wi-Fi module. This is our main concern today. Okay, so we have Wi-Fi module which name is ESP8266 Wi-Fi module. After that, how we can connect? We have the pinouts of ESP8266 over here. Then we have a 3 volt. Okay, so ESP8266 works on 3 volt and Arduino works on 5 volt. So when we give supply to Arduino board, I think this diagram is not visible. Can I refresh? Yeah, now it's visible. And now I guess everything will be shown directly. Yeah, from current side. So interfacing Wi-Fi module to Arduino Uno. What we do? We connect ground terminal to the ground of the ESP8266. Then we have two communications line, like receiver and transmitter. All the three connections here are connected to the 3V3 pin, that is 3 volt, and one connection is to the RX and another connection is TX. So we will connect the Wi-Fi module to the serial port. So that's why we have to concentrate on UART communication. So I think ma'am said that computer engineers are also there, but these are the basic hardware connections, so that you can connect this Wi-Fi module to the internet of your home, and from there you can send the instructions. This Wi-Fi module can capture that instruction, and and the controller can actually work on that instruction. So basically, if I send a instruction like turn on LED from my mobile through a Google Assistant, then what exactly happens? I give an instruction to Google Assistant, then it will process it um, through a web application. Then my Arduino will receive that instruction through this ESP8266. Okay, let's zoom on the diagram. Change the size. Forgive me about this. Okay, now it is visible or not? I have zoomed the diagram. Yeah, I have pasted the diagrams to PPT. That's why they are blurry. That's why I'm explaining them. Because generally, this thing is done through a protest. I guess you all are aware about protest. So we will connect to a easy EDA, or we use a protest to connect to complete a circuit diagram. And this is the image. That's why it's a bit blurry. Okay, so now it's visible as our session is regarding the Android application, and we are preparing a board to connect to actual Android applications. So now concentrate on this diagram. Basically, what it is, I will again explain it. This is a ground terminal. So are you all of you are able to see the points 1, 2, which are the 8 connections? Analog to digital converters. Okay. Where are they come from? Puja color. Yes, we have completed the ADC. Now we are on the Wi-Fi module, which is ESP8266. Okay. So now black wire denotes that it's connected to ground. Then pink wire connected to receiver terminal. Then all the 3 red wires are connected to the 3-volt supply, and then the green one is connected to the TX terminal. So we have crossed the connections. TX of the Arduino is connected to the RX of the ESP8266, and RX, that means receiver pin of the Arduino, will be connected to the transmitter pin of the ESP8266. So this is very important connection through our seminar. Now I will move. Hmm. So, so anyone can note that what we have seen. We have seen. I will write it on the chat box. We have seen ADC of the Arduino controller, which is analog to digital converter. Then what we have seen, the GPIOs. Then we have seen the serial monitor, that is UART. UART is can someone write the full form of the UART, which is Universal Synchronous Asynchronous Receiver Transmitter. Serial monitor, which is UART. I have written it. Then what we have seen, the Wi-Fi, the Bluetooth module. Bluetooth module HC05. Then now I am at Wi-Fi module, which is ESP8266. Okay. So these are the basic requirements when you are using not only Arduino, but you are using every board, Peak, ARM, STM, everywhere it is very important to know these interfaces. Mm, okay, now I need to check. Now I will show you one list from using all of these, what I have mentioned, which projects we can build. And this is very important for the third year students, third year and fourth year students. So these are my classes advertisement. This is not required right now. Okay. So we learned ADC. Okay. So I will explain you what exactly is the application of the ADC, Industrial Temperature Monitor System. So anyone can draw block diagram on their own for their reference. Okay, so what I will do, I will explain. This is a data logger. What is data logger? We are sensing the real time things like temperature, light intensity, air quality, or any analog value, and storing it to the controller is data logging system. So we can develop a data logger if we have a knowledge of ADC and how to interface ADC with the Arduino. So how many projects we can do? We can do industrial temperature monitoring system using with the help of that information. So industrial temperature monitoring. What is difficult in that? There is nothing in this project. We have interfaced only one temperature sensor, LM35 or any. So we have various sensors according to industrial level, but here for prototyping purpose, we have connected one LM35 sensor to the Arduino. Then we have connected LCD to check whether it is showing a correct temperature or not, and we have connected one buzzer. So temperature sensors, LCD, and buzzer. Three interfaces are there with the Arduino. So we can develop an industrial temperature monitoring system using Arduino board. Again, we have light on off based on sunlight intensity. So this is basically a street light monitoring project. We can do it within a day using Arduino, of course. So street light control, again street light control project is there. Then multi-zone temperature monitoring system. The name is very fancy, but it is not that difficult. In this system, we will place our LM35 sensor to various rooms or various places. Then we will get three values from each sensor and we will display it on the LCD. So this is what we call a multi-zone temperature monitoring system. So what exactly is the connection with the web application? This is a wired connection from a sensor to the controller. And now we will automate it through a Wi-Fi network. So what we will do, we will interface three LM35 sensor to three analog pins like A0, A1, A2. Then we will get the data and store it on the memory of the Arduino, and we will transmit the data through ESP8266 to our web application or any mobile Android app. So this is how we do a Android application. This is industrial gas
Excuse me.
tank monitoring system.
Can you please zoom in the screen? The students are not
Yes.
able to see the screen.
Okay, ma'am. Okay, sir. Is it visible now? I have okay, like chat room. Connection to the server time. Okay, in the flow of telling you, I forgot to check the chat box. I'm so sorry for that. Pooja is asking me what is the Wi-Fi module interfacing. I guess it is zoomed in. Okay. Okay. So now it's clear. What is Wi-Fi module interfacing? We are connecting our Arduino board to the Wi-Fi. So basically we have modem, a router at the home, and how we are connecting our mobile to the Wi-Fi. That's how we connect our Arduino to the Wi-Fi using ASP8266. So this is the Wi-Fi module interfacing. Okay. So this is the another example, tire pressure monitoring and control. So this thing, tire pressure monitoring, this thing is giving us a pressure and it is an analog value. So we require a ADC for that. So we will get a A0 pin to measure the pressure. Then we will display it on the display or our web application. Then we have another things like relay and buzzer. Relay is to cut off the power. If it is excessing the pressure, then we will cut off the power. That's why we need a relay. Then we need a buzzer. Okay. So I have told you about accelerometer also. So accelerometer based bridge health monitoring system is another project which we can do using ADC. So here the microcontroller is interfaced to temperature sensors and also controller is interfaced to IR and LDR sensors and the accelerometer sensor so that we can monitor the temperature, the presence of people and the tilt of the bridge. So these are the day-to-day life examples where we can do it. It's hazardous environment monitoring system. So many times we use the same sensors like temperature, gas, fire, LCD, buzzer to monitor the environment. Then we have a car dashboard monitoring system. So this is the most widely used project right now, talking thermometer. So what it does, controller is interfaced to the temperature sensor which is placed on in the patient's body. we are giving audio indication for the low high body temperature via buzzer. So I'm talking about this talking thermometer for blind people. Now again we have another project like intelligent material management system. Here controller is interfaced to load cell. Load cell gives a analog value which is continuously monitors the weight of the stock. Okay. Now I will move to IoT project. Fine. Okay. So we will start with some robotics projects like 4-channel RF based pick and place robot, 4-channel RF based firefighting robot, solar tracker robot, and surveillance robot with a camera interface. So these many projects we can, I have 100 list of 100 projects over there, and using all the 5 basics we can develop any project. So I will share the PPT with you so that you can study afterwards. Okay. So now we will come to actual web application development using Google Assistant. So how many of you use OK Google feature of the Google? OK Google, call my mom. OK Google, call my so XYZ friend. Or OK Google, turn on light, turn off light. Have you used that feature of the Google? So Yashaswini, what feature you have used about the OK Google app? Many times it doesn't listen to us, but I used OK Google, please locate the coffee shop near me. Basically, we use many times. Okay, who is saying many times? Azhar is saying many times you have used the OK Google Assistant. So we will control our home appliances using Google Assistant, saying, "Okay, Google, turn on my home's light." So it will turn on. So how much cost it will need according to all of you? According to me, it's only a 500 rupees business. Within 500, we can control our home appliances. Using for answers, okay? For calling someone, okay. And also for reminding me something about my work. Okay, nice. So do you think within 500 we can control our home appliances using our phone? Saying, "Okay Google, turn on light. Okay Google, turn off light, turn off fan, turn on TV or fridge or anything." Getting answers on exam time. But sometimes Google is not correct, and we cannot follow the authentic websites. So if you are using it to get answers from Google, then go to the, if you are studying a peak controller, then go to the peak official website. Don't go to any other websites. Yes, reminder. Okay. Okay. So what I have done, I have controlled my room's light using OK Google application. OK Google, turn on light. So how I have done it? See, my phone started listening and turning on and off my lights. So I will finally start with the application control home appliances using Google Assistant. What exactly it does? Google Assistant is artificial intelligence based on voice commands. Using voice, we can interact with Google Assistant and it can search on internet, schedule events, set alarms, control appliances, etc. So all of you given me the same answer. This service is available on smartphones and Google Home devices. Okay, see, my Google is started listening what I am saying. I will come back to YouTube live chat. Okay. Now we can control smart home devices, including lights, switch, fans, and thermostats using our Google Assistant. Okay, I will show you one thing on the smart bulb. Okay, so Wipro has launched a smart bulb application. You can go through this Amazon website, you can search the features, what it does. Screen is not visible right now. Okay, Google open YouTube. Okay. Wipro Wi-Fi enabled smart LED bulb 9 watt. So why we do we need to buy this bulb, or we can develop our own device. So from today you can develop your own device. My screen share is lagging. The service is available on smartphones. Okay. Okay. So after this session, go to the Amazon and search for a smart bulb and read all the description of this, and we will build it on our own. See, we have a App Store, Google Play, IFTTT works with IFTTT also. Then it works with Amazon Alexa and works with Google Assistant. So Wipro's bulb is very smart. It can use anything. Okay. So what we will do, we will start creating. What kind of hardware we need to build the home control home appliances using Google Assistant. So if you have pen and paper, write it down. We need a Node MCU, 32-bit ESP8266 development board. Is anyone listening? Do you have pen and paper with you? Okay, Sanjana has pen and paper with her. I don't know, Sheikh. For you, Sabah. Shake. Yes, yes, yes. You have pen and paper. Then write down the hardware. It's Node MCU, relay module, and 100-watt bulb. That yellow bulb which we all of us have at our home. Then we need our smartphone. We have to enable the Google Assistant over that. We need a Adafruit app on our phone, and we should have a IFTTT sign up. Now let's consider that I have a Adafruit. So I will write it through my chat box. We will go to www.adafruit.io. Can I go? But if I go there, what happens is my system will lag again. Still, I will go www.adafruit.io. Okay. So I have entered the website which I have posted on the chat box, which is www.adafruit.io. So create your account and start working. So I have created the account. After that, I will create a new dashboard. I already have a dashboard saying home automation. So I will go to my profile, then dashboards. I will create a new. I have created one dashboard. You can create a new dashboard. I will go to my dashboard. Okay. Now what I will do after following the above steps, provide a name to the dashboard. Here my dashboard's name is home automation. Then create a new block. So I have created a block, light control. Okay, so for three uh, instructions, It is free of cost. So we will use only 3 instructions. So basically what happens is when I say my Google turn on light, then this button will turn the light on. It will turn to green. Okay, so I have selected the feed saying a toggle button is useful if you have a on or a off type of state. So I have on off type of state, turn on light and turn off light. So I have used the toggle feed. Then enter the name of our feed. It's a light control. Then create it. After creation, select the created field and click on the next step. Do you all need to repeat all the steps again? If it is yes, I will start from. Okay. Home. IO free. Okay. IO plus. Okay. So now create a dashboard. Home dashboards. Okay. I will come to Adafruit. Okay. Yes. Okay. So what I will do? Create a new dashboard. I will do it a home automation. Test one. Description. Demo to students. Great. Students, please follow the steps. Or side by side, you can actually log into the Adafruit website. Create a new flow. Now I will click on this. So on the settings tab, we will click on setting icon. I have posted it www.adafruit.io. I will post it again. It is www.adafruit.io. Okay, now I will click on it. Then I will start creating a new block. Create a new block. So what we have on our button, reset button, slider button, gauge, then we have image over it. We have many blocks. Actually, it is very interesting. You can really try it out. So I will select a toggle. Enter a new feed name. My feed name is light demo 1 because I already have a light feed over there. So now all of you can see all the buttons. It's my home automation, so I am turning on and off lights. So I have selected the toggle button. You can select it according to your requirement. Not an issue about it. Okay. So now I will create. Now I have feed. Then I will select a feed. Then I will click on next step in a block setting. So this is what we call a block setting. This is a final step. So what is it? I will give the light control demo 1. Okay. So button on text should be on and it should be off. Okay. I will create a block. So basically what I have a button on my website. So basically what I can say, my dashboard is ready for IoT applications. See this button and off. Okay. Profile, dashboards, home automation. What I have is okay. So this is my light control. Okay, may I start with my Google Assistant? Turn on light. Okay, Google, turn on light. Okay, Google, turn on light.
Turning on light.
So everyone is listening, right? My Google Assistant is giving me back a response that yes, I am turning on light. Now, for more details, we will move towards IFTTT platform. If this, then that, also known as IFTTT, is a free web-based service to create a chains of simple conditional statements called applets. Now an applet is triggered. Okay, so wait, I will see the questions. Is there any question? No, question is not there right now. So Pooja has a question. Yeah, okay, that is not important right now. So if this, then that, also known as a IFTTT, is free of web-based service to create a chains of simple conditional statements. For example, an applet may send so I have to something else. Here I used IFTTT to use Google Assistant service and Adafruit service in a chain. So when I use Google Assistant to control the light of my home by saying, okay Google, turn on the light or off. See, my Google Assistant again has started working. No, I don't try. I made it now. So we will start configuring our IFTTT platform. Is everyone is with me? So basically what I have a button on my website. Let's move to the presentation right now. Okay. So basically we will move towards the block diagram. What exactly is happening? Again, I will zoom it in my diagram. I will do, I will start StreamYard. I don't want it. I will take it. Login, make it start. Continue with Google. Hello? Okay, got it. Maybe later. All in one, created by me. I want to show you what I have created. So this is my IFTTT thing. So basically what we are doing, we are logging in to IFTTT platform. Then we will continue with our Google Gmail account. Then create we can create an account on IFTTT. After account creation, click on My Applets and then select New Applet shown below. So I have already created the applet. For new applet, what we will do, okay, this screen is very lagging. What exactly is happening? Again, I will zoom it in my I will start StreamYard. Hello? Basically, we have apps for Adaptive website and IFTTT website. Both of them can work together. So I will click on My Applets. And then I will create a new one. what I
Okay.
got in.
Got it. Maybe later. Like created a line. I want to show you what I have created. So this is my activity thing. So basically what we are doing, we are logging in to IFTTT platform. Then we will continue with our Google Gmail account. Then create we can create an account on IFTTT. After account creation, click on My Applets and then select New Applet shown below. So I have already created the applet. For new applet, what we will do, okay, this screen is very laggy.
I will add something in if this. We have to link both the websites. So if we'll create
What exactly is happening?
whose voice is that?
Basically, we have apps for Adaptive website and IFTTT website. Both of them can work together. So I will click on Marketplace. And then I will
Hello? So basically I have used it right now. It is saying applet ran at March 27, 12:19 p.m. So what we will do, we will create a if this then that window. For applet, my applets, I have created the window. If you say turn on light, then send data to light feed. So what exactly is the light feed? We have created a light feed here. So it will send a data to the light feed. When I say turn on light on my Google. Now if I say turn off light, then it will send a light feed to the Adafruit platform and it will turn off the light. So what value will be sent to Arduino? The value will be 0 or the value will be 1. Mhm. Okay, so we will easily connect to two websites. One is adafruit.com and one is ifttt.com. I will send the link to ifttt.com. Got it. So basically, create, then I will add if this means if I get a voice command from my Google Assistant, I will add a Google. Yeah, I got the Google Assistant. Then I have a phrases. What I want to say, I will say turn on light. Another way to say lights on. Another way to say light. Uh, what lights? Only lights. What Google will say? Google Assistant will reply to me that yes, turning on light. Yes, turning on light. So there is one my favorite examples of Iron Man. I think girls should also be a fan of Iron Man, and Iron Man has a phrase saying Jarvis do this, Jarvis do that. So we need to create a robot saying Jarvis clean my place. Jarvis make a Maggie for me. For me, it's a Maggie. Then we can command our Jarvis accordingly. Now we have covered two websites, which is Adafruit website and IFTTT website. Apart from that, we have covered the Arduino and the ESP module. What we need to do is we need to connect the Arduino ESP to the power supply. We have a set of commands over there to turn on light, and we have a Google Assistant with us, and we will do turn on light. Then Google Assistant will connect to a Adafruit website through a IFTTT platform, and it will virtually turn on this button, and then it will give the instruction to our Arduino based board, and it will turn on the light using relay. So the block diagram of showing this. I will show you from the current side what I have explained right now. This is my phone with a Google Assistant. I will ask my phone to turn on light. Then the command will be sent to a Adafruit website saying turn on light or turn off light. The connectivity is through IFTTT platform. Then this will go this will go to our node MCU, and from node MCU we connect one small relay as a switch to our light, switch light on or off via relay. So have you understood the flow? Okay, so node MCU is nothing but a Arduino board with ESP8266 already mounted on it. Of course, it has a different pinouts. So basically, D1 is connected to the controlling pin of the relay. Then 5 volt is given to the relay and ground is given to relay. Now I have connected the AC bulb through the relay. So positive end is connected to one pin and through another pin it is connected to ground, and the negative pin of the bulb is connected to the ground. So basically you can do connections on at home, and you can actually deploy the code on using on node MCU. So for the requirements on the Arduino platform, please put your questions. For 1 minute, I will open my home automation code. See. Okay. Okay, students, for more details, you can contact me on my
Thank you,
email.
madam, for your knowledgeable session.
Thank
The
you,
next
ma'am.
session will start at 1:30, 2 o'clock. The next session will start at 2 o'clock. So everybody should be present at 2 o'clock. The attendance link is being shared in your WhatsApp groups. You can mark your attendance. Thank you.
But
Good afternoon, everybody. Welcome to day 2 of the workshop Android-based automation. This is the fourth session of this 2 days workshop. Today's speaker is Mrs. Vidya Pramod Kodgirwar. She has completed her ME in Electronics with first class from Jawaharlal Nehru Engineering College, Aurangabad. And Madam is pursuing a PhD from Electronics and Telecommunications, Savitribai Phule Pune University, Pune. Madam is now working as an assistant professor in PES Modern College of Engineering, Pune. Madam, you can start your presentation now.
hello, madam. Whether my screen is visible to you or not? Hello. Hello, my screen is visible or not, madam?
Yes, ma'am, it is visible, ma'am.
Okay. Now just tell me whether PPTs are visible.
Yes, ma'am. One second. Yes, ma'am, it is visible.
Okay. Okay. Now I think I can start the session.
Yes, ma'am.
Okay. Okay. Okay, students. Good afternoon. Okay, and now we are going to see some basics related to the robotics domain and how the advancements are taken in the robotics. Okay. Okay, in this session, actually, we will see some basic types of robots, then application, advancements, then sensors, then different driving systems required in the robotics, and then end effectors, actuators, some programming methods. Okay, means almost we will cover all the aspects related to the robotics. Okay. Okay, first of all, let's see what is the robot. I think nowadays everybody is aware about the robot. Everybody is known what is the concept of the robots. Robot means what? It is a system which contains sensors, manipulators, power supplies, control system, grippers, then driving system, softwares, and all together performing the some task, okay, and that is called as a robots, okay. And robot is nothing but the machinery or a machine which can perform the repeated task. Robots are a product of physics, mechanical engineering, structural engineering, mathematics, and computing, all collaborated to design, build, program, and test the robots. And robotics means what is mean by robotics? It is a domain, or robotics being a dynamic field requires instrumentation, controlling, artificial intelligence, medicine, chemistry, mechatronics, nanotechnology, and everything, okay. Means robotics is a field which is a combined field from the all domains. That is nothing but the robotics. Okay, now students, you can do the career, or you can have the career opportunities related to the robotics. Like you can work as a robotics technician, then computer programming, or you can make career in the sales and marketing, or you can have a career in software engineering, clinical and laboratory research, applied process engineering. All these fields are related to the robotics. Okay, then already we know that means there are different fields related to the robot or application domains. Means broadly we can specify the robotics applications in like industrial robots, military robots, aerospace robots, healthcare robots. In many, not only this, in many application in agriculture field, in many application we can use the robots. Okay, now if we see the industrial robot, then what is the task of industrial robot? It is an automatically controlled, programmable, multi-purpose manipulator, programmable in 3 or more axes. Means industrial robots are again, these are divided in 4 basic parts, like articulated robots, Cara robot, Delta robot, Cartesian robot. Delta robot is also called as parallel robot or Cartesian robot. We'll see one by one all these types, but before that I think you must know some basic terminologies related to the robotics. Generally when we design the robot, we must know the what is mean by axis. For example, suppose we want to reach at some particular point in a straight plane, then 2 axes are sufficient, x and y. But suppose we want to reach at some particular point in a space, then we need the 3 axes, x, y, z. In addition to these 3 axes, there are 3 more axes, which is called as roll, pitch, yaw. Roll means what? Suppose there is a movement in clockwise and anti-clockwise direction related to x-axis, it is called as roll. If there is a movement in y-axis, it is called as pitch. And if there is a movement in z-axis, it's called as a yaw. Okay, roll, pitch, and yaw. These terms are also related to the robotics. Then another terminology is like end effector. End effector means what? Whatever is the tool or gripper or any device connected at the arm of the robot, then it is called as a end effectors. Then DOF. DOF is also very important concept actually related to the robots. It decides how flexible your robot. DOF means degrees of freedom. Okay, and generally minimum the robotic arm is having 3 DOF, and maximum depending on your structure, means how your robot is complex. Depending on that, we can introduce the more number of DOF. If we compare with the human arm is having from wrist total 27 DOF are there. But that much amount of flexibility is not easy to implement in the robotics applications. Then joints. There are basically 2 types of joints in the robots: rotational joint and transitional joint. Rotational joint means what? It is also called as the revolute. Means if the movement is rotational, then that type of joint is rotational joint. Transitional means suppose your movement is linear, means only in sliding motion in forward and backward direction along the axis, then it is called as the transitional joint. Then some more concepts are like work envelope. Work envelope means your robot, it is related to the robot volume or workspace or work volume. Means whatever is your end effector, up to what level that end effector can move, and that is nothing but the work envelope. Means total work area of the robot. Then payload is also there, reach is also there. Payload means what? How much amount of your robot can carry the load. Load carrying capacity is called as a payload. Reach means how much is the maximum distance that robot can extend without moving from its space, is called as a reach. Means suppose robot is fixed at some place, and that robot can reach up to 2 meter, then it is called as the reach of the robot. Or footprint. Footprint means installation space. How much amount of installation space is required? It's called as a footprint. These are some basic terminologies related to the robots. Now we'll see what is the articulated robot, SCARA robot, Delta robot, and Cartesian robot. Actually, these four are the uh, types of industrial robots. You can see here, this is a articulated robot. Okay, basically, what is the articulated robot? It is means like a human arm, and generally this articulated robot is having three concurrent prismatic or rotary joints. You can observe here, this joint is rotary joint, then this joint is also rotary joint. This articulated robot is with the 6 DOF. 6 DOF means the joint can move in the 6 direction. Therefore, this robot is having the 6 DOF. And main advantage of this articulated robot is like it has a large work envelope, small footprint. Footprint means just I told you, footprint means amount of space required for the installation. That is the footprint. Small footprint is advantage. Then work envelope is large. Then it is very flexible. Then it can be operate with very high speed. But of course, in this type of robots, these robots are more complex. Means they require more complex algorithm compared to the other types of the robots. Then another type of robot is a SCARA robot. This is a SCARA robot. You can observe here. SCARA means what exactly? SCARA means Selective Compliance Assembly Robotic Arm. That is nothing but the SCARA robot. Generally, SCARA robots are designed with the 4 DOF. 2 DOF parallel to the rotational joint, and 2 DOF are the transitional joint. It is related to the transitional joints. And this SCARA robot is good vertical stiffness, and compared to the articulated robot, the number of joints are less. And this SCARA robot, you can observe the videos. Videos are available for SCARA robot, articulated robot, and very interesting videos are actually available on the YouTube. And this robot is also required the small amount of footprint, and then we can use this SCARA robot for the high speed operation. Then for actually these articulated robot and SCARA robots, or generally any industrial robots, are required to perform some task repeatedly. Okay, means therefore repeatability should be very good for this kind of robots. And this robot, but only limitation is that this SCARA robot can reach up to only certain point. Means we cannot extend its end effectors like this. Means, for example, suppose it can reach up to this point, we cannot extend up to here. Okay, therefore it is less flexible compared to the previous, and compared to some more robotic arm or robots, motions or movements are also limited in the SCARA robot. Then another robot, this parallel robot. It is also called as a Delta robot. Delta robot or parallel robot. You can see here, the main advantage of the Delta robot is that these are the lightweight robots. Okay, but these robots are having 4 DOF. 4 DOF means degrees of freedom. 3 transitional and 1 rotational. And again, this delta robot also can be used for applications like pick and place application, or for packaging, or in some pharmaceutical applications we can use this parallel robot. And but as weight of this robot is very less compared to the that articulated robot and SCARA robot, therefore the operating speed is very high. Means these robots can operate with very high speed because they are lightweight robots. And installation space requirement is also very low compared to the SCARA and articulated robot. And then this reliability is very good, accuracy is also very good compared to SCARA and this articulated robot. But with at the same time, the payload for this robot is small. Why payload is small? Because these are the lightweight robot. And payload means what exactly? Payload means the load carrying capacity, and the load carrying capacity of this type of robot is small compared to the SCARA and articulated robot. Then the last type of the industrial robot is a Cartesian robot, or a gantry robot. This is also called as a gantry robot. Basically, Cartesian robot or gantry robot means what? They can have only the transitional movement. Okay, means rotational movement is not possible with the help of this type of robots. Generally, these robots are having 3 prismatic joints. Prismatic joints means what? They can move forward or forward and reverse direction in x axis, y axis, and in the z axis. And but compared to the delta robot, the payload capacity of this robot is good, and speed is also very high, and accuracy more. Cost is less compared to the SCARA and articulated robot. Okay, these are some basic types of the robots, industrial robots. And these industrial robots can be used in different applications, like material handling application, then pick and place application, or we can transfer the material, or palletizing. Palletizing means loading, unloading, or machine loading, unloading. Then some applications are like welding. Again, of course, when we are going to use the robot for welding purpose, the welding gun is your end effector. Means at the end here, just a minute. Here you can see here you have to connect the welding gun. Then spray coating for painting, or for spray coating application, for cutting, grinding, for assembly, for inspection, for monitoring. For this industrial application, we can use these industrial robots. Then here you can see, this is the graph, or top 10 countries by robot density. Means if you consider the Japan, yes, of course, Japan is at highest position, and they have developed a different kind of robots. Almost they are using 295 different types of robots. Then Singapore 159, then South America 164, like this. Okay, from this graph you can see the different types of robots are available. Then Italy is having 124 different types of robots, US using 86, like this. Means robot density, industrial robots per 10,000 manufacturing workers. Okay. Then another domain is that military robots. Means robots are used in industrial application, as well as in military application, as well as they can be used in the farming, agriculture domain, or in medical field. Okay. Military robots are nothing but the autonomous or remote control devices that are capable of taking surveillance photographs, and even accurately launching missiles at ground targets without a pilot. Okay, and basically means this type of robots are military robots. And basically, what is the purpose of these robots? With the help of these military robots, we can clear the minefields, then deactivating the bombs, or wherever there is a hazardous situation, or wherever humans' life is in risky position. That time we can have the robots clearing buildings or risking money instead of a human life. Yes, means if we, instead of human, if we use the robots, of course we are investing the money, but human life is more important than the money or than the machine. Okay, and therefore in military domain we can use the robots like this. These are some examples of the robots which are used in the military. Dragon runner, then Talon, Acer, Packbot, Big Dog. Actually, what is this? These are the name of the robots. Different robots are designed for the different application, different purpose. But of course, they are also used as a rescue robots, and they are used for the military purpose, military applications. Then aerospace robots. Aerospace robots are used in the aerospace for space applications. Aerospace robots are used for the outer space exploration. Aerospace robots are unmanned robotic spacecraft, plays a key role in outer space probe. And basically, what is the purpose of the aerospace robot? Because gravitation is means very less, in very less gravity we have to work there. And instead of again keeping the human life, we can use the robots in many applications. Scientists can explore in outer space without putting themselves in a great danger, considering the risk involved. If they go to outer space themselves, with controlled robots, the same results can be achieved safely. Yes, instead of going themselves, if the same operation or same task is performed by the robot, then it can be more safe compared to the human being. Okay, and the risk to lose a human life in outer space has been avoided. That is actually main purpose in the aerospace. Then healthcare robot. Healthcare robots are generally used in the medical applications. Magnetic microbots are a group of tiny robots used in various operations, such as removing plaque from a patient's arteries or helping with ocular conditions and disease screenings. In medical application, actually, in some cases, very small, tiny robots are used in some operation, or sometime to remove the cancer cells, or sometime to remove some internal part. We can use the very small, tiny robots in the medical applications. With the proper tools and setup in place, proper healthcare could be delivered to the patient, even in remote areas, without the corresponding risk involved. With proper tools and proper setup, we can use these robots. It also provides a facility to move supplies such as medicine, lines, and food from one space to another. Yes, you might actually, in this situation now, in today's situation, the healthcare robots are very, very useful. Means in this COVID situation, instead of keeping the human life in risk, we can send the robot to deliver some food or to deliver the medicine. Or you might have seen in many big hospitals, they are using the robots. One tug robot working 2 shifts a day saves the labor of nearly 3 full-time employees, yet they cost less. Means this is actually example. Tug robot is actually one robot used in the hospital, and that robot can work in 2 shifts instead of using the human. Or we can save the labor cost, as well as you can save the human life also by using the robots in the healthcare system. Okay, actually whatever these applications domains we have seen, these are the basic. Okay, healthcare robot, military robot, but in addition to this, there are some advancements. Means robotic field is very vast field actually, and very advancements are taking place in the robotics domain. Robots are humanoid robots are available. Then swarm robotics is also there. Then prosthetics is also used in the robotics. Then neural network prediction. Okay, basically what is the humanoid? You can see humanoid means what? The robot is like a means shape size of the robot is like a human, and that type of robot is called as the humanoid robot. And there are some examples of the humanoid robots. One main example is that the Robonut 2 R2, that is the one main example for the humanoid robot, and it has been developed by the NASA and General Motors in 2010. And This robot is actually capable to work in space where the gravity is very very low, and radiation is also high. In that situation also, that humanoid robot can work. And of course these robots are very very fast compared to the human, more dexterous, more technologically advanced compared to the human. Then the errors are less, and fast is very high. And in this robot, the DOF is 3 DOF, means this robot was developed with 3 DOF in the neck and 7 DOF in each arm, and that robot can hold the 20 pound in any position. Then you can observe here, all these are nothing but the top 6 humanoid robots. You may be aware about this humanoid robot. This is also very very famous humanoid robot. Sophia is the name of this humanoid robot. You can see this image of the Sophia, and this Sophia is actually the creation of David Hanson. Means it is created by the David Hanson, and this Sophia is nowadays Sophia is at the top position. Means it is very very favorite and popular in the media. Then another humanoid robot is the Junko Chihira. The name of this humanoid robot is Junko Chihira, and it has been developed by the Toshiba. And Android based programming is used in this humanoid robot. And main feature of this humanoid robot is it has the ability to make the expressions like a human. Means this robot can generate the expressions. Then actually this is developed by the Toshiba, and it can be work at a tourist information center, Tokyo. Now it is placed at the tourist information center. Then one more humanoid robot, which is also famous humanoid robot, Irika. The name of this humanoid robot is the Irika, and it is developed by the Hiroshi Ishiguro. That is the name of the developer, and he is a director of intelligent robotics. And the main skill of this robot is like this humanoid robot can recognize the human voice, then human tracking, then natural motion can be generated. Means again natural motions means some expressions, this robot can develop some expressions on the face. Then another robot is this at fourth number actually, Geminoid DK, name of this robot. And you can see here, these all robots are means they looks like a human, and their shape, their expressions, their size is like a human. That's why they are called as a humanoid robots. And then at fourth position, this robot is there, and name of this robot is Gemini DK. And this robot is again developed by the Hiroshi Ishiguro. And again, this robot actually this robot resembles like robotist Henrik Snarf, which is the professor at Aalborg University in the Denmark. And to develop this robot, they have spent almost $2 lakh. And this robot is also can give the response for the human emotional, means it also work like a humans. And this robot is also having more DOF in the neck, in the arm. DOF means what? The movement, how much number of movements this robot can develop. Then at 5th position, this robot is there, humanoid robot. And the name of this humanoid robot is Nadine. And this Nadine is developed by the Nanyang Technological University, Singapore. And this robot is also, it also looks like a human, but it looks, or the face given to this robot is like a Nadia Magnant Thalman, and she is a head of Mira Lab at the University of Geneva. Then the skills available with this robot is like eye-to-eye contact while speaking. Then this robot can remember the people who, and this robot can even recall the conversation, and whatever is the previous conversation, this robot can recall. Then this robot can express some emotions after conversation, like happy emotions, sad emotions. These are the ability available with this robot. Then at 6th position, this robot is humanoid robot is there at the 6th position, and name of this humanoid robot is Jia. And this robot is developed by the Chinese team headed by Chen Jinping, University of Science and Technology, China, Hefia. This robot can also move the arm. Then this robot can also create some facial expressions. Then it can give the answers to the humans, or conversation with the human is also possible with the help of this robot. Okay, these are the specialties for the humanoid robots. Then another field in the robotics is swarm robotics. Okay, this is little bit different than the previous domain. This field, advanced field, is the humanoid robot, and this is nothing but the swarm robotics. In swarm robotics, actually, the group of robot work together, and they can establish the communication amongst them also. That is the main principle behind the swarm robotics. It is actually new approach to the collaboration of multi-robot system, and these multi-robot system work in coordination, means they can communicate with each other. But most of the time, the in swarm robotics, the basic design of single robot is simple compared to the another type of robots. Means you can see here, generally the small robots work together in the swarm robotics. Actually, what is the swarm robotics? Means it's a swarm intelligence, which is nothing but the artificial intelligence techniques. Swarm intelligence is based on the artificial intelligence, which collectively operate together, and their behavior is collective and decentralized and self-organized. Their behavior means they can operate self-organized manner. And generally, these swarm robotics is made up of the agents who interact with each other and in the environment. Means basic concept behind this robot is they are designed to perform like a group behavior. Means their working principle is based on the group behavior, generally which is found in the nature. Means, for example, suppose the swarm robotics or some group of robot is developed to behave like an ant or to behave like a birds. Okay, you can see here, this is a group of drones, and a group of drones can behave like a group of the birds. Okay, and basic principle of the swarm robotics is means they are developed based on the group behavior. Then one more field in the robotics is very important. This is also advanced field, prosthetics. It is called as a prosthetics. Prosthetics means what? It is an artificial device that replaces the missing body part, or if the body parts of the human is lost due to trauma or due to some disease, or if any their congenital condition, or if any accident, if some human lose their body part in some accident, then it can be replaced by the some automatic devices, which is this. Therefore it is called as the prosthetics. You can see here, this arm is the artificial arm connected here, or here also the artificial arm is connected. Actually, this is a very recent advancement in the robotics, and due to this, it is possible to create the prosthetics that can duplicate the natural movement of human legs or human hands, or for some another parts also it is possible. Here you can observe the leg is replaced, and this leg means some kind of artificial intelligence is provided here. Therefore, the natural movement is also possible with the help of these artificial legs. Okay, and then one more domain is also there in advanced robotics, and that is a neural network. A neural network is also very important domain. Neural network means what? It is a network where scientists have produced a computer that operates like a human brain. That is nothing but the neural network. And this is some advancement in the robotics. In some study means scientists have found that a computer was allowed to browse the net, and they asked to computer if it could come up with the own image of the cat, and that is also possible. Means that computer has created the own image which was very accurate. Means that it is just some one example in the neural network. Means you can have any type of machine, you can give some emotions to that machines also, and that machine can detect, that machine can predict also. Prediction is also one more important field in the robotics. Means scientists can develop some algorithm, or scientists can develop some machines, like they can predict some future things based on some historical data set. Means for example, forecasting, or some one more example is like you can see whether sensex is going up or not down, or what are the future predictions in the stock market. That is also possible. And but prediction is of course it is based on some previous database, and that is also some advanced field in the robotics. Okay, then we can see in any robotic application, means whenever we are going to develop the robotics application, the main component in robotic application is a sensor. Okay, of course, in any automatic machine, in any embedded application, in any robotics application, you have to start your system from the sensor. You have to select the sensors based on some criterias. Initially, you need to select some sensors, and then you can use some what we can say, signal conditioning. After sensor, signal conditioning is necessary. Means that may be amplifier, it may be filter, it may be attenuator, or any kind of signal conditioning is required after the sensor. And then after signal conditioning, you need ADC. And because generally your microcontroller or microprocessor can can deal with the digital data, not with the analog data. Therefore, you need some ADCs. Sometimes ADCs are inbuilt in your controller or processor. Sometimes you need external ADCs. And then after conversion of that signal into digital, then only your processor or controller can perform, or processing is carried out. And after that, again, then you, after the output of the microcontroller or processor, you need to convert that digital data into analog. Therefore, you need the DACs. And then you, after conversion of that signal into analog, you can interact with the external real world. Okay, and therefore, in any robotic application, you have to consider the taxonomy of the sensor. Taxonomy of the sensor means on which basis you are going to select the sensor. Of course, you have to go to the top-down manner. You have to start the what are the requirements. Then you have to analyze all those requirements, and then you can select the specific sensors. Therefore, what is the first step while selecting the sensor? Specification of the task requirement, means for which task you need the sensor, means for which task you are going to develop the robot. Based on that, actually, you have to select the sensors. Means, for example, whether your task is localization or slippage detection or size confirmation, for inspection or defect testing, because you can develop the robot for any task. Because main advantage of the robot is it can perform repeatedly. Robot can perform the task repeatedly. Therefore, you have initially you have to identify the task requirement. Okay, then choice of modality. Choice of modality means what? For which purpose you are going to select the sensor, whether for vision system, or to detect the force, torque, or to detect the touch, tactile, like this. Then specification on sensor attributes, means whether your sensor is which type of data sensor is giving, which kind of attributes are available with the sensors, or what is the output, whether the sensor is giving analog output or digital output, or which what is the range of that output. Okay, then what type of input is required. You have to think all the attributes related to the sensors. Means whether the, for example, output, complexity, discrete or continuous variable, means your sensor output is in the discrete form or it is in continuous form, or imaging, non-imaging, or your local, global, all these attributes you need to consider while selecting the sensor. Then specification of operational parameters. Yes, means you need to consider size of your sensor, accuracy, how accurate that sensor is giving the data, cost. While selecting the sensor, you have to consider these parameters also. These parameters are also very important. Then selection mechanism means your sensor is switching device, or it is inductive type sensor, or it is capacitive type sensor, or it is resistive type, or it is a charge coupled device, or for it is used for the vision imaging. Okay, means whenever you are going to select the sensor, you have to consider all these factors. All these factors are important. Okay, then these are some examples of the sensors used in the robotics. Resistive sensors are there. There are so many types of sensors, actually thousands, more than that also different types of sensors are available. But generally, these are the common sensors used in the robotics application. Resistive sensors, bend sensor, then potentiometers, resistive photocells. These are the examples of the resistive sensors. Already you might have seen these sensors. Resistive sensors are very common. Then tactile sensors. Tactile sensors are actually contact switch or bumpers type, means they give the output in the digital form. And some sensors are contact sensors, some sensors are non-contact sensors, some sensors are internal sensor in robotics application, some sensors are external sensors. Internal sensors are required to identify the movement of the joints or arms or links, means by how much amount of angle you want to move this joint. For that purpose actually you need the sensors. Then infrared sensors are non-contact type sensors. It is a reflective type, proximity type, and distance sensor. Basic three types are there in the infrared sensors. Then ultrasonic distance sensors. For infrared sensor, actually the range is limited. These are non-contact sensors. You can find the distance, you can detect the object, whether object is present or not present, with the help of the infrared sensors and ultrasonic sensor. But range of the ultrasonic distance sensor is more compared to the infrared sensors. Then some sensors are inertial sensors, means these sensors measure the second derivatives of the position. Means you can detect the position. And example of this inertial sensor is accelerometer and gyroscope. Generally in drone, gyroscopes are required. Then orientation sensors. You can detect the orientation of the object with the help of these sensors. Examples are like compass, inclinometer. Then laser range sensors, vision sensors, then GPS system. These are actually the sensors required in the robotics applications. Okay, sensors generally looks like this. This is a physical appearance of the sensor. You can see here, this is a pendulum type resistive sensor, or you can detect the tilt with the help of this sensor. Then this is a piezoelectric sensor, piezo bend sensor. Piezoelectric sensor is actually active sensor. Whenever external pressure is applied, they generate some amount of voltage between these two end of the robot. Piezoelectric material is used here. Then resistive bend sensor. If this strip is or if external force or pressure is applied, then resistance of this strip changes. Then one more sensor you can see, it is a series cell resistive light sensor, which is also called as a LDR, light dependent resistor. Resistance of the material changes depending on the light intensity, and by detecting the light intensity, you can check whether external object is present or absent. Like this, many sensors are there available, and depending on your requirement, you can select the sensors. Ultrasonic sensors are also there. Magnetic sensors are there. Okay, then as like a sensor, another important system or another important component of the robotic system is a driving system or a drive system. Actually, drive system is why drive system is important, because to actuate the end effectors, you need the drive system, or to apply some kind of movements, or to apply some driving force, you need the drive system in the robots. There are basically three types of drive systems in the robotics, that is hydraulic drive system, pneumatic drive system, and electric drive system. Basically hydraulic drive system means what? It is actually based on some fluid in okay, one by one we'll see. This is the example of the hydraulic drive system. And basically hydraulic drive system, working principle of the this hydraulic drive system is based on the Pascal's law. What is the Pascal's law? Pascal's law says that if the pressure is applied to any part of the confined fluid, then it transmits that pressure in the another part with no losses. Okay, and this pressure acts equally on each part, and this pressure can generate the force equally on the external walls. Okay, and actually that is the Pascal's law. And in any hydraulic drive system, this Pascal's law is applied. Basically, what is that hydraulic drive system? It is designed actually to transfer the energy from pressure differences, not from the kinetic energy. And this pressure is generated by using the hydraulic fluid, which is based on the mineral oil or water. You can see in this diagram, the pressure is generated, and of course, to drive this hydraulic system, we need the motors. Okay, means you can say a hydraulic drive system is required for the heavy payloads in constructional buildings or in constructional sites. Generally, the automatic machines are used, and these automatic machines are the hydraulic machines, or these are operated with the hydraulic driving systems, and their payload is very high in the hydraulic driving system. You can observe here the working principle of hydraulic driving system is like this. If the this is drive, the pressure of this liquid is generated, and this end effector or end arm will move in this direction or in this direction. If the force generated by this liquid is more here compared to here, then obviously the movement of this arm will be in this direction, and it may be opposite also. And this is actually with the help of this sensor, we can detect the position of this end effector. And once the position is detected, then the feedback can be given here to this amplifier, and this amplifier, based on the this reference voltage, it will generate the error, and depending on that error signal, the this system will work. Means this will move in this direction or in this direction, and according to that, the pressure will be developed. In this way, actually, the hydraulic drive system works. This is another example of the hydraulic drive system. You can see here, suppose the pressure is applied in this direction, then this part will move in this direction. If the pressure is applied in this direction, then this assembly, mechanical assembly, will move in this direction. Okay, and this liquid flow will flow here, and due to the flow of this liquid, the pressure will be created, and this end effector will move in this direction. Okay, in this way, hydraulic drive system works. Then another drive system is a pneumatic drive system. Basically, pneumatic drive system, working principle of pneumatic drive system and hydraulic drive system is same. Only the payload capacity of the pneumatic drive system is less compared to the hydraulic drive system. In heavy payload system, we can use the hydraulic, and where the payload is less, there we have to use the pneumatic drive system. In pneumatic drive system, actually, conversion of compressed air power into the mechanical energy is created. That is the main working principle. Compressed power is converted into the mechanical energy, and compared to the hydraulic drive system, pneumatic drive systems are less, means they can operate the light load compared to the hydraulic drive system, but these are fast compared to the hydraulic drive system. And you can see these are some components in the pneumatic drive system, like intake filter, then compressor. This intake filter is required only to pass some air particle. If another particles are there, that will be removed. And then compressor is required to compress the air. And then cooler is necessary, because when air is compressed, automatically the temperature of that air increases. Therefore, again, we require the cooler to decrease the temperature of that air. Then separator, if any, during cooling process, if any water particles are there, that will be separated, and only air is passed here. Okay, and then this receiver will collect the air, compressed air here, and then that air is passed to the actuator, or it is also called as the end effectors. and with the help of this control wall, we can move this end effector in this direction or in this direction. That is actually the working principle of the pneumatic drive system. Okay, this is another example of the pneumatic drive system. You can see here, in any robotic application, either we have to use the hydraulic drive system, pneumatic drive system, or electric drive system. Okay, working principle is almost same. Compressed air is here, and then this air will move in this. Due to this air, the end effector will move in this direction. Okay, then electric drive system. In electric drive system, actually, there are many types of electric drive system. Main component in electric drive system is the different types of motors. DC motor, again in DC motor, DC shunt motor is there, DC series motor is there, then separately excited DC motor, or PLDC, or BLDC, permanent magnet DC motor, brushless DC motor. All these are the different DC motors, and servo motors are necessary in the electric drive system. Again in servo there are two types of servo motors, AC servo motors and DC servo motor. The servo motor actually takes the feedback. That is the main component in the servo motor, and based on the feedback, actually servo motor means whatever is the feedback taken with the help of this sensor, position sensor or speed sensor, then that feedback is given to the controller, and depending on the feedback, this controller generates the error signal, and based on that, actually the speed of motor increases or decreases. This is nothing but the power processing unit. This power processing unit increases or decreases the speed of the motor. This is actually working principle of the electric drive system. Many types of motors are used in this electric drive system. This is the example of the electric drive system. Okay, then one more component in the robot is gripper. Gripper means nothing but the end effector, or some kind of hooks or scoops are used, or tools. Tools are there also there as an end effector. Means, for example, spray painting gun is there, or welding gun is there, or you can see the in automatic drilling machine, the drill bits are there. Okay, these are some tools, external tools connected to the end effector. Basic four types are there in the gripper, that is mechanical gripper, vacuum gripper, magnetized gripper, and adhesive devices. These are the four basic types of the grippers. Actually there are so many types of grippers, but mainly these four grippers are more popular. And gripper means, again, it is also end effector, and mechanical grippers are with two or sometime three or sometime four fingers are also there, and these fingers are actuated by the robot controller in mechanical grippers. Only limitation for the mechanical gripper is that actually they are rigid, but the size and shape of the object is fixed. In case of the mechanical gripper, means when the mechanical grippers are designed, they are designed for some specific type of objects. Means we cannot change the size of the object if the mechanical grippers are designed. Then another type is vacuum grippers. Vacuum grippers, there are again different types of suction cups used to hold the flat objects. The advantage of vacuum gripper is that these gripper can hold the flat objects of any size, and if the object is plastic or wooden type, then also possible. Means we can hold that object, we can pick the object, we can place the object, or we can mount in some mechanical assembly. For that purpose also we need these vacuum grippers. But the gripping force generated by vacuum gripper is less compared to the mechanical grippers. Then magnetized grippers. Magnetized grippers, the advantage of this magnetized gripper is that any type of object can be gripped. Means any type of means, of course it should be only metallic object, but if the shape of the object is irregular, if the size of the object is not fixed, or if the surface of the object is not smooth, then also it is possible with the help of the magnetized gripper. In case of the vacuum gripper, the size or surface of the object should be smooth. Then only vacuum suction cups are applicable for that object. Then last type is adhesive type, adhesive devices. Adhesive substance is used to hold the flexible material. Okay, this is also one more type of the gripper. Basic 4 types of the grippers are there, mostly used in the robotics applications. Okay, and then these are some examples of the gripper you can see here. See here, you can observe the you can say this gripper is having 3 fingers, but it's not like that. Actually, this is a mechanical type gripper, and this is 1 finger and this is another finger. Means this gripper is having only 2 fingers. If there is a movement between this finger and this finger, then you can say there is a set of 3 fingers. Otherwise, there are only 2 fingers. If all these 3 fingers are moving simultaneously and these 3 fingers are moving simultaneously, then this gripper is designed only with 2 fingers. And if there is a movement possible, separate movement is possible with this finger and this finger, and then you can say total 6 fingers are there like this. Then this gripper is also with 2 fingers, mechanical gripper. This gripper is vacuum type gripper. This gripper is also with only 2 fingers. Then this is also vacuum type gripper. Then some more examples of the gripper. You can observe this is a magnetic gripper. Then this is also mechanical gripper. Then this is also mechanical gripper, but this gripper is designed to hold the object with smooth surface. Okay, then we will see the different programming languages used in the robotics. Actually, to design any robot, we need to program that robot. Okay, without programming, we cannot design any robot. For example, suppose there is a face recognition program in a robot. Then which steps are taken by that program? Initially, that face recognition program will take the image of an person as a input. Okay, that program will accept the image as an input. Then it will scan the image for a specific set of features. Once the image is taken as an input, then it will extract some features from that image. Okay, then compare these features to a library of known faces. Then whatever the features are extracted, that algorithm will compare that features with the known library features, or whatever is the previously stored data. It will compare with that previously stored data. And then it will find a match. If there is a match, then it will return the name of the person as a output. This is the output of the program. Now actually the program will perform the same way, or any time, or repeatedly, or whenever this program is executed, it will execute all these steps. Okay, and actually these are the common steps, or depending on the requirement we can program the robot. Okay, for generally in any robot you need either complex microcontroller or microprocessor to program the robot, and depending on your application complexity, you can select the microcontroller or microprocessor. And microprocessor is one component of the microcontroller. And how the controller works or processor works, it will simply fetch the instructions from the memory, or it will fetch the byte or part of the instruction from the memory, and then that byte is internally decoded with the help of microcode. Microcode is internally available with each microprocessor. Then that byte is decoded, and then after that, after decoding, that controller or processor will understand what is the meaning of that decoded byte. Means if next incoming byte is a part of the same instruction, or whether it is part of the data. It depends on the decoding or meaning after understanding the meaning of that first byte. And after decoding that byte, then it will perform the actions. Means then it is executed. Whatever is the meaning of that byte, according to that, it will perform the action is takes place, or execution. Means fetching, decoding, and execution. Okay. And in most of the advanced microcontroller, microprocessor, all these three tasks are parallel tasks. Means parallelly, fetching unit fetches the byte, and at the same time decoding unit decodes the previously fetched byte. At the same time, in same time cycle, the execution unit executes the previously fetched instruction. Therefore, all microcontroller and processor behaves in a same way. But of course, to program the controller processor, there are different languages. Many programming languages are available. There are some, actually in robotics, more than 1500 languages were used. Means so many different languages are available to program the robot. Many manufacturing companies using their own languages. They develop their own language and they use their own language for their robot. But still, some common languages are there, like C, C++, C hash, .NET, then Java, then Lisp, Prolog, MATLAB, Python, then HDL, then Basic and Pascal, then Microsoft C hash, .NET, Scratch. These are some common programming languages used in the robotics, and these languages are very popular languages. But still, out of all these languages, most commonly used languages are C, C++, and Python. Python is nowadays, it's becoming at the second position actually. C, C++ is always at the first position, and then after that, the popular language is a Python. C, C++, Java, Fortran, Python, so many languages are there. But first and most popular language in robotics is C, C++. And after that, Python. Python is also very popular due to its use in machine learning, and also because it can be used to develop a ROS package. ROS means what? Robot Operating System. There are additional important software tools. Means in addition to these languages, we need some software tools like ROS, Robot Operating System. Actually, there are so many OS, embedded OS, then mainframe OS, then real-time operating system, Android OS, smart card OS, and different types of operating systems are available. As per your requirement, you have to select it. But in robots, or whenever we are using the Python or C++, we can use the ROS. ROS is a set of software libraries and tools that helps you build a robot applications. You can also write your own programs for ROS in C++ or Python. Means you can upgrade the ROS. You can have the your own programs in the ROS. Means you can, it is an open source, and you can upgrade this operating system, robot operating system, by using your own programs in C++ or Python. Then another tool, software tool, is a MATLAB. This is also a popular tool. MATLAB, which is used for data analysis and interfaces with ROS. You can interface the MATLAB with ROS. Also, Octave is a free open source equivalent to MATLAB. Okay, means Octave is also one important tool, software development tool, and it is also freely available. It is open source and it is also compatible with the ROS. Okay, then in many robotic application, you can use this Arduino microcontroller development board. Okay, this is not Android based, huh? It is a Arduino microcontroller board. There are two boards are available with Arduino. One is with Atmega 2560. Atmega 2560 is also one microcontroller, and Atmega 328. Atmega 328 is a low-end microcontroller. Means for small and simple application, you can use Atmega 328. And for some more little complex application or for robotics application, you can go for the 2560, Atmega 2560. Number of IO pins with Atmega 2560 is more compared to Atmega 328. Microcontroller, these microcontrollers is the component that you program. High level code that you write is compiled down to machine code that is embedded on this chip, and the pins at the top and bottom are connecting input devices such as sensors and output devices. Yes, means with the help of this development board, you can connect the external devices, you can connect the sensors. Actually, this development board, on this development board, readily there is a crystal, or readily you can use the switches, reset switch, or some devices like ADC, DAC, then power supply is also available here. Directly you can download the program in this development board, and easily you can interface the sensors, and you can interface the external motors or relays, or any external displays like devices, and you can develop the robotic application. You have to start from the scratch. You have to start from the small robotic application, and then you can make your career in the robotics. Okay, and then another is Raspberry Pi. This is a Raspberry Pi development board. Again, you can have this development board for the robotic application, and with the help of Python language. To use means a Python language is applicable, or it is compatible only on the Raspberry Pi. Python is a useful language to learn as it is widely used in computer science and machine learning. Nowadays, in machine learning, in artificial intelligence, in many vision system, robotic vision system, you can use the Python language. With the help of that Python language, you need this development board, that is Raspberry Pi. Python is a language that is used with the Raspberry Pi. Yes, this makes it highly relevant to robotics because one can use a Raspberry Pi to control a robot. To control robot, to control or to develop the robotic application, you can use the Raspberry Pi. This is also development board. Also, some devices are available on this development board, like crystal, or many external devices like or ADC, DAC, power supply, and easily you can interface the sensors. This connector is provided here so that you can interface the different sensors, or you can interface the different external devices, input devices, output devices, with the help of this connector, and you can develop the any robotic application with the help of this Raspberry Pi. Okay, and then there are certain advantages, disadvantages with this robotic domain. What is the main advantage of the robot? It increases the productivity. Of course, in industrial application, you can use it to increase your productivity, to increase the safety, efficiency, quality, and consistency of your product. Then robots can work in hazardous environment without the need where human interaction is not possible. In that cases, or in that situation, you can use the robots. Then robots need to Robots need no environmental comfort. Of course, means in heavy temperature or in heavy rainfall also robot can work. Robots work continuously without experiencing fatigue of problem. Yes, means like human, robot can work continuously. Means unlike can human, robot can work continuously. Robots have repeatable precision at all times. Repeatable precision means what exactly? Without any errors or without any kind of fatigue, or robot can perform the same task repeatedly without any errors. Robots can be much more accurate than human, of course. Once it is programmed, it will work properly. But of course, there are some limitations also. Robot can replace human workers. Yes, means the productivity increases. One robot can perform the task of 3-4 humans workers. Robots can process multiple stimuli or tasks simultaneously. Simultaneous tasks cannot be also assigned to the robots. But at the same time, there are some limitations. Like robots lack capability to respond in emergencies. If any sudden emergencies arises, then robot cannot respond. Means they can only work whatever they are programmed for that. Okay, means sudden if any emergencies are arises, then they cannot respond. Robots, although superior in certain senses, but they have limited capabilities in degree of freedom. Of course, means if we develop the robotic arm, then there are less number of DOF compared to the human arm. Means in our human arm, flexibility is more. Because in human arm there are 27 DOF. 4 DOF are available with single finger of the human. Okay, and that kind of flexibility is difficult. Then dexterity, sensors, vision system, real-time response, that is difficult in the robots. Robots are costly due to initial cost of equipment, installation cost, need for peripherals, need for training, need for programming. Yes, initial cost is more in the robots. These are some limitations, but compared to the limitations, advantages are more. Therefore, one can go or one can think about their career in the robotics. Finally, I can conclude the session by telling that robots are really generating the robots is really amazing. Uh, Robust series of innovations has made robotics the answer to many challenges, from disaster response to military safety. Yes, I mean, you can say there are many advantages in many domains, from the disaster responses to military or medical application. In many domain, we can have the robots. Okay, I will conclude my session. If any queries are there, just a minute. Hello, madam.
मैडम एंड करता है क्या सेशन? हेलो, am I audible, madam?
The YouTube also. Just a minute. Audible, ma'am. Just a minute, sir. The YouTube also. Just a minute. Just a minute, sir. Okay, sir. Just session is concluded. Any queries are there? Hello, am I audible?
Is there any query from the students? If you want to ask any question to the ma'am, please ask in the comment box or in the chat box. Is there any question from your side, students? Okay, shall we conclude the ma'am?
Yes, sir. Yes, no problem.
Wait.
Sir, shall I leave now? Hello?
Just wait, ma'am. 2 minutes.
Okay.
Just 2 minutes.
Okay. No problem.
Thank you so much, ma'am. So we would like to thank the management of Desha Women's College of Engineering, Solapur, to give us this opportunity to conduct this 2 days online workshop. We would like to thank DAY-2 University for sponsoring this workshop. We would also like to thank the principal of the college, all the participants, all the speakers, and the participants will receive certificates after 1 week, depending upon your attendance. Thank you once again, everybody, for your cooperation.
Okay, thank you, madam.
The workshop has ended. Thank you, everybody.